I'll start recording.
Okay. Cut the chit chat. That's what you're saying.
Well, if we say something inappropriate, we're not gonna publish it. It's okay. You know.
Something inappropriate.
Dan!
Oh, I recorded the last one, right? But I
we didn't scrub it yet. So let's do it. Offline. Again, it's best effort. So don't worry about that. So APIs.
Are these the only 3 ready for review?
There's a list. I just didn't open all of them so that we can pick and choose.
So Imo sent an agenda before he left, and today some of the CoreFX Lab APIs were on the agenda. I prepared one of them for the review. It's ready. The other one is not ready.
Yeah.
I'd also like to make sure we get to 21.537 today.
Yeah. So So we have pretty good large backlog. So do you think that what you sent can wait because you sent it today?
It's very small, but I invited Ason and Josh for the review, so it's gonna be the second hour.
Okay.
Because I thought this is triage.
So this is not triage.
It's an API review, right? I don't know why people calls it triage, but whatever.
Let's do the ones that are high priority for these guys, since the others.
Yep.
Yeah, it's basically the first one, adspan, binary reader writer. But as I said, let's wait for Ason.
Yeah, I was actually, thinking that we should maybe do some of the, read memory and that stuff, a little bit as a priority. Anyway, let's start with the backlog. James Coe was actually poking at this one, why it's not reviewed yet. So I think we owe it to him. So immutable array, and he wants to try to what? To immutable array. He wants it on the immutable array builder, and I guess immutable dictionary builder. On builders, he basically wants a transfer. Anyone familiar with the immutable classes? Oh, this is update. Oh, this is older. Yeah, this is the latest. Yeah. To me, it seemed to be why not?
I don't understand what are these convenience methods? I mean, this functionality already exists. What is it that's?
Here it is. Right. I think it's convenience, as you say.
Yeah, so this comment says something about, it's already an extension method, are we moving it?
Yeah.
So is it just a move?
No, I don't think that it's a move. I don't think that we have he was changing, member methods to extension methods probably based on some feedback. We can check it out.
I'm not familiar with the builder types.
Me neither, so.
These are.
This is API comparison. This is discussion. So actually, original content was, to put it on directly on the class builder, on the builder class, and there was probably some feedback saying that's not a good idea. Can get to that. Yeah.
Immutable arrays, Christoph? Wasn't Immutable Array a project that you were involved in?
I was a bit involved, but
with Andrew.
I was involved in reviews, but
Okay. It's not like Span. It's not your baby.
Yeah, we should use this recording as this is why we ask you to fill the full template with the motivation and everything, because it's just hard to search for it to all the viewers.
So from skimming this quickly, it seems like the issue is there are existing methods that are just named differently from extension methods, and so when you use the extension methods, you get the slower behavior, and so he's proposing adding versions named the same thing, so when you compile it, it binds to the more efficient one, I guess? Is that...
I didn't get that part of that. It's original.
I mean, these functions are already there. They're just named differently, right?
Are they?
I mean...
Well, they should be.
I mean, the whole purpose of a builder is to create the thing. So there's a way to go from immutable hash set builder to an immutable hash set.
So is the problem that we have like an IEnumerable dot to enumerable array that it's binding to, or what?
That's my understanding from reading through or from skimming through the thread in like 30 seconds.
I'm just reading it.
Okay, yeah. So immutable array has an extension, well, maybe extension method, probably extension method. Yeah, over an IEnumerable called toEnumerable array. So I guess the only thing I can think of is that they're trying to intercept that binding because people are calling toImmutable array when they just meant to call toImmutable.
Yeah, that's my understanding as well.
And
they're calling what today?
So immutable array. Not immutable array of T, but immutable array.
Oh, they're calling the two. I see, and it goes through IEnumerable.
Yeah.
Okay, so that's
it's
inefficient.
taking the builder, turning it to an enumerable, walking it, figuring
I
out the
see.
link, going back. So it has to do a rebuffered walk when it's already buffered in the builder, which is why the proposal is to specialize.
But then both of these methods will show up on the API, correct?
yeah, that's the bit.
You get an overload of two immutable array. You have one that takes an IEnumerable and one that takes a builder.
But C# should, because it's a specific type on the builder, it should pick the right one without any, necessary to cast and things.
So
Really what they're saying is they wish that when we had made the method, or builder.toImmutable, that we had called it toImmutable array.
So if I have existing code and I recompile it that does toImmutable array, it'll now become more efficient. But what Christoph says is true, that I'm going to hit dot and now see. I guess I'd see both anyway. I already see both.
You would already see both.
No. You don't see toImmutable array on IEnumerable. You only see toImmutable, correct?
No, so looking at the shape, immutable array of T has a nested type called builder.
Yes.
So if you have an immutable of T builder, that has an instance method called toImmutable. But apparently people are calling .toImmutable array, which is binding to immutable array .toImmutable array of T, which is the extension method that takes an enumerable. So they see in IntelliSense toImmutable and toImmutable array, and they write the one with the longer name, which is the slower function. That's the hint. It's got a longer name. There's more code there.
So binary compat we're not gonna help them, but next time they recompile, they will at least pick the efficient one, which makes sense.
So
bit of success.
I understand what it's intending to do, this feature, but I wonder whether it's going to accomplish what it intends to accomplish.
Why would it not accomplish what it intends to?
Both methods will show still people will have problems.
Well,
which one.
it's both methods already show up.
Yeah.
Now it doesn't matter which one you call, you still get the fast behavior.
Because C# will pick the right overload for you, and an overload will do the right fast thing. It's not going to do the casting explicitly to IEnumerable.
They just want this extension method to forward to the instance method.
I think I understand. So the builder implements IEnumerable?
Yes.
Yeah.
Oh, okay, I missed that part.
Yeah.
Okay.
No, I assume.
I mean, yes. Otherwise, this makes no sense.
Yeah.
Okay, now I understand. Oh, wow, builder implements IEnumerable.
Check it out.
Yes.
IList, so yeah.
Immutable array of T .builder is an I collection, an IEnumerable, an IEnumerable of T, an IList, an I-read-only collection, and an I-read-only list.
I believe you.
Yeah, you'd find it from immutable array more easily.
Any comments? Are we okay approving that? Seems reasonable to me. Honest. Okay, so API approved as described in top post. For future, please put there. For proposal, we had to fish out Okay. And it's gonna work, yes. Approved. And that looks like a grab should be fairly straightforward, and I bet that James is gonna jump on that, so. Should be fairly straightforward. I think no public API is the most complex part. Okay. Next. An API to get an assembly name that doesn't throw on a native binary. So it's adding the try get assembly name, which returns false instead of catching exception but image format exception.
So what's the problem with the try catch code?
It's try catch code.
It's verbose and also throws an unnecessary exception.
So we added try pattern for performance reasons.
Come again, we added try.
What?
We added what? So try pattern.
Like pattern.
Okay.
For performance reasons. The guideline says if throwing exceptions is too slow for your scenarios, you should consider try pattern. It's not to fix syntax of exception handling. Like, I don't think we should be doing this. Well, it's such a slippery slope. Like, all APIs basically that catch exceptions, now we're going to have try APIs and we back to error code. Like, that's not the purpose of try pattern.
I agree with that, but is it true that there's no cases where this is a performance problem? I mean, I've certainly debugged code where I kept hitting bad image format where it's reading files.
You do crack open every DLO, look at their versions, and you basically can't distinguish whether there's a native or managed assembly.
Exception overload in
startup path.
It hits this seriously. Yeah. Like exceptions are slow, but only for
just loading assembly and throwing one exception. It's like
it's not slow. It's also debuggability. I think try is reasonable to increase.
That's also not the reason for that's not why we have try, because basically if debuggability is an issue, then again, it applies to literally every single API in .NET framework. Like, we shouldn't be throwing except. That basically says we shouldn't be throwing
I mean, most APIs don't throw when you use them as intended. Most of the time, throw. That's not the case, right?
I think majority of our exceptions just throw. I mean, there are precondition exceptions that yes, you can you can kind of know how to use the API and not pass null if it checks for null. So yes, those I agree with you, but many other exceptions where they are not like precondition checks, like you can get they will be throwing sooner or later in real programs. So I kind of don't like the trend of us saying we don't like how C# syntax looks, therefore we're gonna try APIs.
I think that
fix the C# syntax.
I think that point may have been conceded. My point is I've debugged code where I keep hitting this over and over in the debugger, and I wonder what that's like.
We should also so we should have a meeting are we fixing the problem with the debugger, or we are throwing away exceptions in .NET, like we are not using them anymore except for preconditions. Like one of those two is a self-consistent guidance, but I wouldn't one-off, somebody, this day somebody doesn't like an exception here, so we add try method, and where does it stop, or does it?
I mean, it's possible for us to define something between those two extremes, right? Where a method is often called many times, and in the normal course of events will often throw, we could maybe say it's reasonable to have a try.
So we went through this, lots of people basically said exactly what you said. And the problem is, I can give you kind of a history of the guidance. around exceptions. It's very difficult to define what is normal, what is not normal. It so depends on software. Like, people were saying, like, out of memory is, not normal. Well, if you, like, SQL Server and you grab all memory on the machine, then actually out of memory is very normal. And, like, I would basically say we should change guidance and not changing APIs one by one for things like this.
My question on this would be, do we have an API that you can identify that something is an assembly as a Boolean without involving a throw? Like, could you write this to avoid the throw?
You can't do that, though, because you have to crack open the assembly. You're basically going to do reading an assembly twice.
But maybe that's true, but that would avoid a try. Would you be comfortable if we had is assembly?
But first, if we are talking about this specific issue, I would say first, whoever filed the issue, Eric, should say, is it syntax that he doesn't like, or is performance that he doesn't like?
Performance and debuggability.
Or debug, because the issue doesn't even state why he doesn't like the code that he
wrote.
Chris,
but I think
so one by one. If it's syntax, I would say we should talk to the C# team. And actually, that is my position, by the way. I do think that our syntax for exception handling is really
I don't think that's
unnecessarily
the crux of it. It's just the fact that you have to catch the exception and you have to you deal with the performance.
So anyway, one is syntax, one is performance. But for performance, we have a problem. Like if it's performance, then we have chai parse. It is designed for it. In this particular case, I would like to see a proof that it's actually impacting performance at all, because exception throw is like 100 cycles for simple exceptions, and loading a DLL and analyzing is like it's millions.
So for you, adding an API like isAssembly would be an anti-pattern, because now I'm not 100 cycles, I've handed the disk twice.
It's not 100. It's a bit more about it's super small in comparison to loading.
In a tool, you wouldn't care calling isAssembly and then load assembly, especially if only a fraction of the files are actually assemblies.
No, you would care, because you don't want to be cracking those things open twice every time.
Yeah, the cost is in actually opening the file, loading.
That's going to be more costly than
we don't want to do that twice. Exactly.
Yeah, I just wondering what the purpose.
So it can be syntax, it can be performance, it can be debuggability. I would say if it's one or of the others, we need to first decide which one, and then think about what is the solution for our platform, not one by one kind of an API.
Well, in these cases, I think it is one by one. In a lot of cases, because
this API is has a performance.
If it's performance, I agree, because we already have a guidance for it. I'm saying I would like to see,
because the exception syntax.
Because I would be really shocked if it's a performance problem in this case. Like it's loading stuff from disk. Like what?
But it shows up tons and tons. We're cracking every binary in the toilet chain.
If exceptions were even in the ballpark of loading stuff from disk, then
so how would you if he had data here that said that this would make a ASP.NET thing start up 50% faster? Would you say that's sufficient?
50% stuff?
I said if it,
of course.
Okay.
I'm saying if there's any proof that it's
measurable,
it's measurable, then yes, that's what try is for. I'm saying, but it's not for fixing C# syntax or debuggability of debugging Visual Studio.
I don't think anyone thinks this is a performance issue as written.
Yeah.
I disagree. I think the MS build team and the compiler team will definitely think it's a performance issue.
Well, ironically, that was what I spent many years
not the fact that exceptions are being thrown from time to time.
Right.
That's right. As much as I'd like to say it was performance, I mean, it's
so
hard.
at one point there was basically a big jihad about normal cases of launching BS should never have first chance exceptions.
It comes in waves, and I did it when they had the new editor. Suddenly, thousands of exceptions when you start up, and I mean, that was maybe a perf thing, but it is a debuggability thing. I'm not saying that try is the answer to that, but throwing exceptions in normal cases.
So if it's not syntax, okay, awesome. So it's not a C# team. It's a debuggability. Then we should meet with the debugger team and think what we do about it. Because again, otherwise we basically are saying exceptions in .NET are broken. Don't use them because they impact debuggability negatively.
Or that.
So
it's one thing to say that never use exception. It's another to say that you should always be capable of determining an is question.
But it's not possible. You cannot before you open a file, you cannot check whether the file exists and then know that your open file will succeed. So there are basically these are like not precondition issues where you cannot check ahead of time.
Yeah, the problem is exceptions don't live up to their name. It's like they're supposed to be exceptional, but actually what they're used for is the API can't do its job, which all too often is not exceptional.
Yeah.
And even if we talk to the debugger team, the problem is like I was sitting in WinDebug most of the time. That's not going to help.
Or VS Code and stuff. Like Visual Studio is not our only debugger anymore.
So you basically try isn't necessarily the right answer, but I think that it's not so simply
what
solved.
you're saying is, if I could kind of paraphrase your position, is we cannot fix the ecosystem, debugging ecosystem. Therefore, exceptions in .NET are broken. Therefore, we should not use them.
And it's one paraphrased.
It's kind of so that's the guidance.
How to kill exceptions in .NET? Okay.
So in the past we used that like exception should not be used for the main code path, right? Or main control flow, or whatever we call it.
Exactly. Everybody states it slightly differently, and there's nobody ever defines what these words actually mean.
Okay.
Therefore, yes, people have been saying this, and we've been saying, please write a guidance that people can understand when to use exceptions, and then people couldn't come up with it. So we have guidance that we have, and as I'm saying, like we should do something because I think there are significant problems in our error handling model, both in the language, in the runtime, in debuggers. But I think it's
there's certainly cases, although they don't immediately come to mind, where we've added is blah API to avoid throwing an exception. Now, in this case, you don't think that's a solution because you crack the file twice. There's certainly other cases where that's a reasonable thing to do.
Well, so I don't think it's even about cracking the file twice, because the is pattern works for cases where there's no race.
Right.
Like the
this one wouldn't be a
stable
race.
preconditions. Here is also a race. So like
it's not a race. This would not be a race.
What do you mean?
You're asking whether or not a file is managed assembly, and then you go and open it up as a managed assembly.
Would have been overwritten.
Then you've got really big problems with your tool. Especially because loading the assembly probably doesn't. Yeah, I mean, does that even lock it on disk? Like, what's stopping you getting changed in a line after?
So I was trying to think of a comparison. One of the comparisons that we have is like the zip library. When you go open up a zip file, and it's not actually a zip file, we throw invalid data or some crap like that. But generally, you don't open it up unless you have some kind of confidence as a zip. So it's got a .zip extension or something like that. This API, they're all .dll extensions, so you can't really even even make sort of like prejudgments like that are cheap before you open it. So I feel like there's something we can do here, whether or not it's a try pattern, maybe another overload or something. Maybe even change the API to return null if it's not.
Get assembly name if managed.
That was returning null was a proposal there, and Eric said he was proposing a different one for
assembly name, but return null if it's not.
Returning null would probably be too big of a breaking change.
Yeah.
So you'd have to have another API of some sort.
Like call, for example, Triage or something.
Get assembly name or null. That's what you.
Well, we're playing games with the name, right? So
okay, so I think that the next step is to defer this and do two things. One is be more explicit about what we actually care about, although I think we know in this case. And then number two is
so Wes is
arguing
this performance.
It's convenience or debuggability.
Either debuggability or syntax, one of those two things, because
no one is. Wes and I spent years of our life debugging through this exception. And so I suggest we defer this and then have some separate time where we discuss this larger problem, which you're right, we should have a principle rather than doing it bit at a time. Of course, that venue is probably here.
Well, maybe the other version of this meeting.
Right.
So I started to talk with C# team about the syntax issue, especially with Jared, because on Midori we had quite convenient syntax for many things like this. Basically, something like the null propagating thing, where you could just call an API, and if it throws
with like bang bang null at the end or something,
give you like some defaults or do like execute an else clause in your language. So we could address the syntax using something like this. The debugger issue is very hard. I don't know. It's harder.
I mean, I don't know if anyone happens to know, but it seems like in the latest editions of VS, like the default for the managed debugger is not really catch anything first chance. Like it used to be that most of the first chance exceptions were checked off, and now I install VS and it doesn't break in anything. I wonder if that's a symptom that they did that.
I think in general this whole feature of first chance exceptions could be improved to actually make it useful, because if it's on, it bugs you too much. If it's off, it bugs you not enough.
In my previous life, like many of us, I spent
first chance exceptions in just my code.
I mean, first chance exceptions to me.
Something like, seriously, I was thinking about something like this where you can kind of say, like, were you interested in those exceptions?
First chance exceptions to me are a wonderful, wonderful thing, having debugged a lot in the native code of VS, where it's like somewhere in this million-line function, someone's not taking an H result.
Yeah, but
to break on the first chance exceptions is probably the issue, or maybe the next one. Yeah. That is a wonderful thing.
But so in native code, because in like Win32 APIs, error codes are used very heavily.
And there's no debug.
It works, correct? Because basically there are error codes, and exceptions are kind of like the houses on fire thingies. In .NET, for historical reasons, we chose exceptions to use for everything. We didn't want to have error codes, we chose exceptions, and then some problems resulted from it.
My point was that it sucks in the native code, because there's no quick way to break, and in VS there's like 1 billion lines to load up a solution. Whereas in managed code, it feels like it used to be in the good old days. You'd break in, and like the second or third exception would probably be the actual issue.
All right. So, is the second item what we concluded? We should discuss general guidance on exceptions from BCL, or does it capture what we wanted to?
I wonder if it's slightly more specific that.
Okay.
It could be useful because it comes up from time to time. I could give like a short presentation on like the history of exceptions, like even like what the guidance are is today, because it's a bit complicated.
In each of those contexts, if you just add it in each of those contexts, that might.
Okay, that's good. Texts. And Christoph signed up.
I could kind of organize something and get the C# guys in the room, maybe get the Visual Studio Debugger people in the room, because it's been bugging me for.
But again, we should keep in mind that like VS Debugger is not the only debugger. That's on Linux and Mac, right?
Sure.
So.
Sometimes you're not even using a managed debugger.
Yeah. Okay. Oh my. So back to needs work. This is super fast today. So this will be the longer one, but we had it for a while. The new math APIs. If it shows up. What's wrong with my laptop? New math APIs. Okay.
So, question about this API: how will it be implemented?
Looks like it's going to be using C++, the CRT.
So we're gonna just invoke to CRT.
Yeah, some of them. That's what we do with a lot of the existing math APIs today.
So rather than asking for that, I'm trying to kind of ask people to not put that in the API proposals. I assume that you're looking at it from the point of view we would, you like the APIs, assuming that we can actually bring perf benefits.
Well, I'm not sure if I like the APIs, because some of the methods are called XM1, which is not very .NET-y name.
Sure.
But the main thing I was kind of thinking about is some of these may be complicated, and they're not there's lots of code.
Yeah.
And if we cannot reuse an existing binary that we already have a dependency on, like CRT, for example, then it will just bloat the runtime potential.
Yeah.
And then, like maybe we should have these operations in some other, external DLL if that's okay.
Like like really advanced, right? Yep. That's a valid point. Like asking for the implementation, or condition like approved, assuming that it doesn't bloat the runtime and with more dependencies and stuff on platforms.
DCW user who's been very helpful in numeric stuff in the past. I think it's his job. Has a bunch of interesting points about some of these are good matches for the framework and some aren't, and some are statistically oriented and some are numeric analysis kind of oriented. And,
as in he's kind of providing data for having them.
Some of these are
useful and some not.
Well, that, and also maybe they should be in different namespaces.
Yeah, there's this issue of like, what's our strategy for math? Is it like we shove everything into the math class, or we have a separate binary for, kind of more advanced mathematics besides the very basic arithmetic operations that are in math today? Like, again, where does it stop? Like, we keep going? Like, everything is in one math class? And math F.
Well, we have a lot of advanced math stuff in the math class today. They're not all basic stuff.
Yeah.
There's a lot of trigonometry stuff in there already.
There's some.
Yeah, but like I don't know that I would expect like the error reducing function to be,
or the gamma function. I'm looking for math abs and I found the gamma function.
Well, what if you want to compute a factorial this way?
Oh, just it's like 15 years of grade school between those two things.
Yeah. Because certainly, the CRT, if they found it useful to add these things, it's probably, in holistically speaking, useful to add these things. I don't know that they all fit on math. Because there's a lot of math you can do, but if, maybe more statistics-y things should be, system numeric statistics.
I think it would be helpful to have Eric Molino here.
So we have system numerics .dll, correct? Something like this.
Mm-hmm.
Should it be our DLL for non-core math operations?
Is it? Wes, do you know if numerics is part of the
World?
Yeah.
Complex and rational. No, or what was the other one in there? Big integer. They're not. And system numeric vectors has been moved into the core library.
Big integer is not part of the shared framework payload?
It might be. I can't remember if it's part of shared framework, but it's not part of core lib for sure.
Well, I guess my question is if we think that the implementation of this is going to be heavily based off of calling into system libraries on all our platforms, then we probably don't want it to be a free-form nougaty thing.
That's right.
But if we already have system numerics as part of the core install set, where it's easy for it to carry around the native, p-invokes and native dependencies and whatnot, then
currently we don't p-invoke into the CRT outside of core lib. That's not that I'm aware of directly.
You can have subnamespaces on math as well. You can have
nested types.
Yeah.
Well, but then that forces them in MS Core Lib and framework.
Where did we put math at?
You can't have a subclass in a different system.
Oh, subclass, yes.
Yeah, so we can't have system.math.statistics without putting it
in a class.
Yep.
Yeah.
So I would say statistics-y functions that maybe we get a class of things under system numeric statistics, whether that be a namespace or a class, and some other things. Yeah, we'll see what.
Another thing kind of related is so Eric is working on the Tensor APIs.
Oh, there you are.
And I wonder if we should
Eric.
Cool. I was freaked out, just like Psychic. But
I just ping him. Very cool.
Sanjay,
okay.
So Tensor is kind of a bit related to this whole space.
So things that have come up so far is, should these be on math? Should these be here at all? And also,
where do we stop?
Are they all likely to be CRT pass-throughs, or are they going to bloat our code? And I think there's a general sort of theme across the different core libs to move more stuff into CRT, try and make it faster and more accurate. Is that not? I mean, for numerical operations, that's not the case.
It's the opposite.
Okay. Why is that?
Because we have one implementation instead of multiple.
I see.
Ideally.
And I guess presumably then performance isn't an issue when you're removing it that way.
Well, ideally we can potentially improve it.
Sometimes the interop call is, like if the operation is super cheap, the interop call is slower than implementing.
And there's also like, we've had a lot of problems where there's different behavior on different platforms in the CRT, and also there's not consistent behavior like between like versions of Windows. They might change the implementation of some of these functions that we call.
Yeah.
So if we actually have a managed implementation, it's much easier to get the same behavior and make sure it's the same.
Do we prefer even not CRT, to avoid CRT? That's what we prefer.
I think so, yeah.
Because these, especially some of these, I assume they are so cheap that actually the interop cost would be significant. Right?
Another thing we're really hoping is with the hardware intrinsics proposal that's moving forward is we can, like some of the things that are not possible to like do outside of the CRT, like use SIMD intrinsics and other stuff like that, should be possible in C# soon. So there's even less of a reason to go down into the CRT.
So do you think these are reasonable on math? I mean, some of them like arcsine and stuff. Well, actually, it's hyperbolic arcsine. That seems reasonable on math, I guess. But hypotenuse?
I think hypot is pretty useful. I don't know about cubic square or the cubic root, but
well, they are all useful.
They're all useful, right?
Correct? So
and they're all like
standard. They are useful, but like, should they be on math?
Right.
Like, do they, are they in the same?
We already have like arcsine and arccosine and arctangent on there.
Right. And do you have shine and cosh and tana?
We do, yeah.
I can't remember how you pronounce tana.
So you're saying basically that you believe the implementation for these types will be in managed code?
I think ideally they will eventually be. I don't know who proposed this?
Tanner.
Yeah. I know Tanner's already done a bunch of optimizations of some of the existing math APIs. In some cases he has just called into the CRT. Like he implemented all of the existing mathf functions, well not existing, all the new ones that he added were in mathf, and he did a bunch of like work in core CLR to make them call into the CRT, etc.
You see, there's actually a comment at the end. It says that he wants to use fcalls and intrinsics.
Yeah.
So intrinsics, that I assume this is basically
that's
the new feature, and fcalls, that's what, copy and paste from CRT?
No, fcalls is basically calling into the CRT, I believe. Fcall is where you call into the runtime, and then the runtime would call into the CRT. Or it would implement it.
I thought we take code, copy and paste into the runtime.
I think it could be either, but I might be wrong with it. It's definitely calling into the runtime, I guess, what the runtime does.
The cost is only once, right? That is only one cost, the fcall, which is the bingo, basically.
It is worth observing, though, that if we do it ourselves, there's actually a lot of subtleties, perhaps more than was necessarily handled long ago in the original implementations, right? And I've seen a bunch of PRs over the last year where people like DCW user and Tanner doing are like fixing like weird cases with tiny epsilon and these ALP things.
So APIs.net agrees with Eric's statement that we do have sine, cosine, and tangent, the hyperbolic functions already on math. So arcsine, arccosine, and arctangent, those belong there as the inverse of the existing function.
They do. Now it becomes clear to me that DCW feedback was referring to a previous version of this, and way down at the bottom, Tanner's extracted that now. So he was objecting to things like,
I think he had way more
remainder of quotient and like the log gamma function. That's probably hard to put on math.
So let's run through one possibility. So I can see like the hyperbolic cosine, sine, arctangent being there because we already have the non-hyperbolic ones. Exponent of 2 looks good to me, log 2 looks good to me. What would we do with something like xm1?
Yeah.
Like, I just don't think I like this. To me,
is the perf so much worth it because of the exp and then you do minus?
Yeah, I think it's just a common like combined operation that's fast.
Something commented that it's more accurate if you know you're doing it together, because you know you can drop off around it. Yeah.
But you see, like I think like an API like this starts like polluting the math class with some very corner case APIs, and especially like I don't know what the name would be.
Do we have like math 2pi, for example?
Right, we have pi. But
right, but I mean, well, you're the graphics guy. Like quite often you have a const for like multiples of pi and things like that.
Potentially, yeah.
Or pi over 2.
We don't have weird ones like we don't have we don't have weird like multiples or half pi's or whatever.
At 2pi you're gonna be at most a bit inaccurate, and at pi over 2 you're gonna be at most a bit inaccurate.
Well, no, I just mean that you normally have them in a const. You don't have to do it every time. Save a multiply or whatever. We already have math.pi. We could have math.2pi.
So are we basically saying that we like them except the exp m1 and lock 1p?
I mean, and I'm also concerned with the names of compute cubic root.
Yeah.
Well, those are terrible.
I mean, we did call square root.
We called square root.
So
yeah.
I know.
The real question is like, does cube root belong on math?
It seems like
square rooting is
exponentially less common than like a square root.
Right. Like the math class for the most part contains things that you would have on a calculator in when you're taking like trigonometry in high school. Like I don't recall my calculator ever having a cube root button. You had to do the manually go take something.
Actually, no, cube root button is quite common.
But now it's 2017.
M1 maybe not.
You had a cube root button on a calculator? I had a square root button.
Yeah, like with a little 3. Yeah, absolutely.
Yeah.
You can even.
Man, you guys have way fancier calculators than I did.
No,
mine had just
square
root and then the like.
I had an
X to the Y.
Jeremy, my calculator had the same things that yours had.
All right.
But my daughter's calculator, it can actually graph on the screen.
You can just run that.
You can write programs.
You can just call math square root.
There's a bunch on math today that wouldn't be on a calculator. Div rem, IEEE remainder, things like that. Round, sine, truncate.
Okay, so what would you call this exp m1?
Windows calculator in Windows 10 does not contain a cube root button. That's my argument.
Is that your baseline?
Did you switch to the?
I'm in scientific.
Wow, you in scientific?
As a straw man, I would take the M1 and change it to minus.
And Google's web X to the Y.
Yeah.
So you'd be like, I want 8 to the 0.3, and that's how you do a cube root.
To the 0.3?
To the 1/3.
Right, 0.33333.
Yeah, I'm tired of typing.
Right, so you're not getting it as accurate as the button.
What about this?
That's the square root.
Is it just square?
Yeah.
We should.
It's an immediate operator.
Yes.
It's just downstairs, right?
Yes.
The M1 is not even raising to the power 1, by the way. You know that, right? It's basically taking the exponential Euler's number up to that and subtracting 1. So
yeah.
And what's the base of
that one's marginal on
Is it E?
Yes.
Ah.
E is the thing you're raising. You're raising whatever you pass into E to that power.
How common? I assume it's a numerics thing. How common is x minus 1 and log 1p?
I know that in the recent refactoring we did for complex, log 1p and maybe log 2 showed up, and also hypotenuse at the bottom. So I know that those were used, and those might have been sort of added just because of that. But it seems like they're fairly common in like algorithms.
So why don't we call log 1p just log plus 1? Just expand it.
Yeah, right. I think that's a no-brainer. If we were going to have it, that's what you'd call it, right?
I think the reason they're as is because that's the names that are in like
CRT.
The standard libraries of C and C++.
We break that on 100 other places, right?
But we do have SQRT,
We don't do strlen and stristro
No,
and
to be fair, we don't do it in a lot of
wustro.
other places.
Yeah, and so, I just Googled log1p and x m1 or whatever that. If those sort of what the gold standard here be, if that was a immediate hit on Wikipedia of this is the name of this formula, then that would be fine. But just because the CRT called it something doesn't mean it's really the.
But it's not. You searched and it didn't show up.
Yeah.
Okay, so
I'm looking on the JavaScript math class.
Yeah, what do they have?
They have they have all of them. They have CBRT.
Do they have?
I don't see E+1.
Do they have Exp at all, or Exp? Exp M1.
What's that one?
Isn't it?
CLZ32, XM1, log1p. Yeah. Well, they also put random on math as well, so it's kind of cognitive. What's the word?
I mean, crypto math uses random all the time. It clearly belongs right there. Math thought I need a random number.
They have square root of half as well.
That was sarcasm.
Oh, square root of 1/2.
Does Java have?
what are we with the random number generators? At some point.
Yeah, there's actual ongoing stuff. Was active Morgan, you mean the hash function or random generator?
Yeah,
no, hash functions you meant, right? Yeah.
We don't have multiple random numbers.
Community is working on that, and Morgan was just
CBRT.
We have two.
encouraging someone. So.
XPM1,
XPM1,
log1p.
System.random. And then
all the proposed ones seem to exist already of both Java, Lang math, and also JavaScript math in the exact naming. Same naming.
The M1 and 1P.
Kubroot, M1, 1P.
CBRT.
That's a strong argument.
Hypotenuse, is that on yours?
So, Tanner is here. For the first time, we meet him and see him in flesh. Hey.
Real. Hey.
We're arguing about naming now.
Yeah, we have
Is it fair to say we were convinced all these should be on
By the way, we're recording.
I don't think that's fair.
No, we are not yet. So that depends on the names. If the names are beautiful, it can be in the core, otherwise not.
That's necessary.
But not sufficient, I think we can
I completely agree with Akash and friends, because we have, not only do we already have cosine and arc cosine, we already have hyperbolic cosine, so we should have its inverse. That makes sense. The rest of the stuff, I don't know that it necessarily belongs. We should make another factory class and not make math be this long.
What about the argument of consistency with Java and JavaScript and C++, you said?
Well, it's the standard C.
So on what type is in JavaScript this API?
Math.
Same in Java.
But they put random as well.
So randomly, let's put random there.
I mean, again, I'm just
I thought JavaScript.
are we gonna just always grow, or do we want to try breaking things in Excel? If you want formulas, you can say I want a statistics formula, and now it starts giving you things to use in statistics. You say I want trig formulas, it gives you trig. Should we keep growing math, or should we start carving out what kind of math spaces we have and put it somewhere under numerics?
So, as for ease of use in today's implementation, probably putting it in math is the easiest, just because that's where all the other F calls are routed through right now. I know that you can route F calls fairly easily to other places, but also for visibility, that's probably, I think, the best place, at least for the core functions here. I did leave off some of the C runtime functions that aren't as well used, like the gamma functions in the error correction. But when the SIMD intrinsic proposal goes in, and we're actually able to implement these in C#, rather than having them be F calls, I think it would be significantly easier to have them in other places.
So let's first talk what is the right thing to do, because sometimes if the cost is 10x, then I think it plays a role, but I don't think it's 10x.
Yeah, I think the cost of implementing these using F calls today, the biggest cost is writing the tests.
So let's say,
anyway. So,
but let's say we wanted to have them somewhere else. I don't think the cost would be unreasonable, correct?
Yeah, no, it would just involve creating new entries in the e-call list, and then
So I was saying, like, let's first talk, like, what is the right thing to do, what we would want, before we talk about the cost.
So I think that for the hyperbolic and cube root, those ones I think should be in the core math class.
So the hyperbolic, we already, as Jeremy said, I completely agree.
I think cube root matches that too, just because squares are also there.
Yeah.
The other exponential and the logarithmic, those are more niche, even so than the hyperbolic. They're really there just because IEEE has weird behavior with really small numbers and really big numbers. And those ones probably could exist elsewhere. And the people who need them would probably be pulling in a numerics library already. The same for hypotenuse. That one exists because you're able to do some computations at infinite precision and then round down, rather than rounding at each intermediate operation. And that one's probably exclusive to people who are already doing things like pulling in system numeric vectors and complex.
So let's say we expand this whole space of numerics and we add more math-like things. Where would we put them? And what would they be?
I don't know, and I don't know what they would be called. And then I fear we'd have like a bunch of smaller siloed things that are hard to discover.
And well, the real question is like, would they have to be in core library and MS correlate?
No.
Or is it something that we can imagine kind of pulling out entirely out of BCL and out of core files?
We have the hardware intrinsics.
Yeah.
Functionality, then they can implement.
That's what I thought. I'm just double checking.
Yeah.
But until then, I think they have to be part of corelib because they're F-calls.
Yeah.
Well, we would not approve them until, we would basically make them block on SIMD.
Yes, okay.
That's the idea. And like the question is how much harm is done, by delaying them by, I don't know, half a year or something.
I mean, I guess they could be like, okay, sort of like guinea pigs for the hardware intrinsic stuff. Like we could put them in CoreFX Lab to start with and then optimize them, see how it works, and then promote them or release them.
Or more into the mythic CoreFX extensions.
Those formats okay to split off just because they're more niche and
well, I mean,
less people will miss them.
A little bit of it does depend on. So, like, if all of these are mostly now like a processor instruction, then they can go wherever. Once we get more processor level capability.
None of them will be singular. They'll be multiple, but and the other limitation on that is there's no. So the most performant implementations of the core math functions in the C runtime currently come from AMD, Intel, and Microsoft, and none of those are open source. So we're either going to have to talk either internally or externally to see if we can agree to get some of that open source as a community effort, or we'll have to go and re-implement those, and that will probably take significant effort.
So the other position would be if we think that this is always going to be calling into the CRT or on Unix systems calling into libmath or whatever, A, so that we make sure that we always give the same answer that a native program will be given, and B, because they can do things like they'll already have written if you support this special instruction, then I'll do it in one instruction or I'll do it in the software 15.
Well, that's what the SIMD intrinsics allows.
And right, but if we're going to end up calling into library functions anyway, then I mean it's not that we need to put it in MS Corelib or that low in core, but we probably don't want it to be a standalone NuGet package because now we're doing complicated, like, I'm jumping into libmath as a p invoke, which grid split packages in NuGet are annoying.
Okay, so let's assume that we have the intrinsics and this, and we can put them into a separate library. I still don't understand, like, what would the library be and what the type would be. Like, we would have a new type called what?
I would think something like it would go into system numerics along with complex and big integer.
And what type?
Possibly math extensions or something. And if C# ever gets extension everything, then you could make that be extensions on the actual system math class if you wanted. But that would also probably be a location where half precision, if that gets supported, or quad precision, IEEE floating point, if that's ever supported.
Like if we were doing it fresh right now, I'd say that we want, system numerics, trigonometry, system numerics, whatever, and that it's each class of functions goes in a helper type of its appropriate naming. The fact that we have this big jumble right now called math means that if we want to make a second one, we're probably just going to make a big jumble. But it would be nice if we could, whatever, maybe we need a system numeric logarithms, and it is just utility functions for doing logarithmic things. So log 2, log with an arbitrary base, like anything else that we would ever add. And yes, it'll look silly right now when it has 2 functions on it, but as we have more need for doing things, and as we have more need for helping people by writing the doing processor level intrinsic stuff that is hard to get right, then it'll grow.
So why do you guys also say that log2 is not used commonly? I think
log2 is actually quite useful. It tells you it tells you the upper bound of the Hamming weight of a value. So.
I think because more commonly people, or even the compiler, like the native compiler, will convert that to a pop counter bit test and just return the highest bit, rather than actually doing a log2 algorithm.
So
there's other optimizations.
Basically, you're saying that if I use log2 for the purpose of doing bit checking and manipulation, I would just not use this function.
Yeah,
because it doesn't have a special code path. Like if it's a power of 2, it's not gonna be fast, correct? It's gonna still do the same exact thing.
Yeah, potentially.
Yeah. Okay, that's what I was thinking. Yeah, in this case, I would just not have those. You kind of have to understand what this thing is for.
So honestly, if you're actually thinking about having math extension or something like that, I think that would be yet another good thing alongside power collections into the CoreFX extensions, and basically have it entirely community driven, because we should not be gatekeepers of how many cool, crazy things in math there should be. There's no need for us to do that.
Again, modulo some implementation details, if it's all things that we're going to try routing through system libraries, I don't think it makes sense to be a standalone NuGet package.
From the reasons it's not possible or it's extremely hard. We can bite the bullet for extremely hard ones.
It's painful to the consumer of a package.
Why?
For one, it makes package publication difficult because the building, you now have the problems that we had with Core 1.0 of you can't build this and copy it to different systems. You have to go build this.
You have to multi-target.
This is the Linux run. This is and the NuGet packages are bigger. And when you hit a platform, if we've moved on to a new platform, but that one hasn't, then now it's just there's a dead tree. You just can't go down that anymore. So I think if we see things being just, this would be libmath and this would be the CRT, that should be in the core distribution, not in a NuGet.
From the convenience perspective, yeah.
Because it's a pain to the user down there.
Well, but if we implement them using the intrinsics, then we don't have this problem, right?
I just don't know how many things the CRT defines that are helping for standardization as opposed to because the processor can do this in an opcode.
Most of the math functions, except for square root, can do it in a single instruction. They are generally 100 plus SIMD instructions with special paths. And they exist because people use math all the time for it. And I know one of the big pain points for math was we didn't have mathf, but now we do. And now the big pain point on that is it doesn't exist on desktop. So if you want to use single precision math, you have to target NetCore, or create a wrapper class in CAS, etc. And I could see the same thing happening with this, at least as long as it's runtime dependent. And the SIMD instructions will be like that for a while as well, presumably.
Well, the desktop versus core angle is independent, right? That is true for any, API. We will have to bite the bullet.
Well, with APIs that are not dependent on the core runtime, users at the very least can take the source code and copy it. And
in practice, nobody does that.
Well, but I think it's that's one thing. But basically, if it doesn't depend on a particular runtime, then we have an option of shipping it as a portable out-of-band component, and then anybody can use it immediately.
Yeah,
so I'm on email thread now with Steve because I don't know what to do with some of the span processing APIs where I would like, for example, people who write Azure SDKs to be able to use them, but they need to be portable to old versions of .NET Framework, and the moment we put them in the core, we exactly run into the same issue. And APIs are just pure IL implementations. They may as well be out of band, and then anybody can use them today. So this is kind of a very similar trade-off.
For this, if there's out of band with required runtime support, then it's not really out of band. It's really limited in its use, and customers don't have a workaround. Whereas at least with others, even if people aren't doing it in practice today, and that may just be because there's not a lot of people multi-targeting desktop versus NetCore or some other reason.
Having said that, this one, so it depends on the intrinsics feature, which is already a runtime feature, correct? So it cannot be portable to previous versions.
Yeah, we would have to multi-target and then have a pure software fallback, and then it's way slower, and we have to maintain 2 versions. And it's
well, aren't we going to be maintaining 2 versions for the software fallbacks, anyways?
Potentially, yeah. If we want to run it outside of NetCore, then yeah.
Well, I mean, even on NetCore, because if you happen to be on hardware that doesn't support the intrinsics for whatever reason,
it's possible, yeah.
Then we
want to support,
have to provide software.
Yeah.
Plus, at the very least, a software implementation provides a consistent, this should be correct, no matter what changes you make.
Yeah, it gives you a baseline, yeah.
So I think the software implementation is going to end up existing for any functions that are implemented.
That's probably fair enough. Yeah.
Okay, so some resolution here. What do we do?
I would approve the first 3.
Okay.
I think the first 3 and cubic
root. And then
root.
cubic root, only Jeremy said that he doesn't like it because his calculator didn't have it.
I don't know any time that I have ever wanted to compute the cube root of something. Square roots I do all the time.
Because you think in 2D, not in 3D.
I guess that could be the problem. Me and my computer graphics class did not get along. If we think it's helpful and we think it's normal,
I don't like the name, but I guess word.
I don't like the square root names either.
Whatever, I can live with that.
I chose cube root like that both because that's what appears on graphing calculators and the IEEE spec as well as everywhere else.
Yeah, we looked at Java, JavaScript.
JavaScript does the same, right?
Yeah.
Dan, check that. Okay. Then
and
we have
the rest, maybe we wait. What would happen if we wait till we have intrinsics and we kind of have a bit more flexibility?
So hypotenuse with intrinsics becomes essentially not needed. Just like a FMA instruction method's not really needed because then users can just call the fuse multiply add hardware intrinsic.
Delete.
Okay.
And then exp2, is that 2 to the argument or e to the argument? Or what?
Yeah, it's essentially POW2 and then number, which you can simulate with left shift.
Yeah. Or if they need something with a fractional exponent, then they can call POW, and if they want it to an integer, they can do left shift.
Yeah. So the benefit, the real benefit of exp2 is if you're actually working with non-integers, then it is significantly faster than calling POW, like order of 10 to 100 times faster, depending on the value you pass in.
It's fair, but I think math is cluttered, and I would say we probably want to have an answer of what we would do with things like ERP and gamma. If we were to add them anywhere, where would we add them before we start being like, well, let's just join everything?
I would say, unless there's urgency, we need them for, We just have to have them now. I like the idea of starting a math extensions project and seeing how far we can run with it in a separate DLL. And then we will at least learn, like, what things are possible, what are not. Once we have, more requests for even more exotic math functions, what to do with it, like, it will answer a lot of.
Yeah, I think that's a good idea. And I've also wanted to do, like, other experimental things that probably wouldn't immediately go anywhere.
Yeah. So Xplot gone, all of them. Okay.
Yeah. So the top 3 are for symmetry, and apparently cube root is popular. So
in modern calculators.
And modern calculators.
2007.
My graphing calculator's not changed since like 1986. TI is still selling the same buttons.
But did it have a cube root button?
Yes. The TI graphing calculators do.
I don't remember.
I think my calculator had like an X root, and then you would type in.
Yeah, so I had a to the like nth root and to the nth power, but it didn't have a cube root button.
I think that's what mine had, but it wasn't any good.
Picture of a TI-86 calculator.
Okay.
This would be the fanciest calculator I ever owned.
And I'm gonna stop recording, and because my computer needs to restart, I'm gonna reconnect again a little bit later. Is that okay, Stephen?
That's fine.
Okay. So this is approved.
Yeah, there's no cube root button on this. There's square root, which is shift square.
Okay, now look at TI from 2017.
TI 89 is what I have.
So it's not recording now?
Still recording, sorry. I'm gonna finish UI review. So this is the,
Yeah, something like
something secret.
$2,000? What the heck?
I have a question that.
Yeah, fair enough. So review for Orno approved API.
That's too low res.
Okay. Good.
Okay. Stupid hide button not actually hiding.
Okay, copy that.